Welcome back to another podcast from the Rooster Podlog. You know what we love to do here?
Deep dives.
Deep dives.
Yeah.
And today's deep dive is going to be all about Apache Spark. And specifically, we have some notes all about how Spark handles big data processing.
Okay.
And we want to unpack these concepts for you. We have some notes about RDDs, data frames, and data sets.
Yes.
And these are kind of the core tools that Spark offers for dealing with massive amounts of information.
Exactly.
But we don't want to just define them for you. We want to really understand their strengths,
Right.
their inner workings, and when you would choose one over the other.
That's the key, isn't it?
Yes.
Knowing when to use which tool is just as important as knowing how to use the tools themselves.
So you've given us some really great notes here that cover all of these, and it can get kind of intricate.
It can.
So we're going to try and really clarify, the
Yeah.
key distinctions and make it really practical
Absolutely.
for every.
Spark can be quite intimidating at first because these concepts are abstract.
Yeah.
But once we break them down and relate them to something tangible, like, say, building with Legos,
Oh,
it all starts to make sense.
I love that you brought up Legos because your notes actually use this Lego analogy, and I think it's such a great way to think about this.
It is.
So let's start there. Imagine we have like a bin
Mhm.
just overflowing with Lego bricks.
It's just a huge jumbled mess of pieces.
Yeah, and they're not sorted in any way.
No.
It's just chaos.
Total chaos.
And this is kind of like our raw data.
It is.
It's distributed, across lots of different computers potentially.
Yeah, that's how Spark works.
In our Spark cluster.
Distributed across multiple nodes.
Right.
So you have these vast data sets scattered all over the place.
Okay.
And that's where the fun begins.
And so the first way that you talk about in your notes of dealing with this is RDDs,
RTDs, right?
resilient distributed data sets,
Yeah.
which sounds very complicated,
Does.
but it's really like
It's the most fundamental way Spark handles this data.
working with the individual bricks.
You got it.
Okay.
Individual Lego bricks spread out across your workspace.
And you talk about partitions within RDDs.
Yes. Partitions are essentially chunks of data,
So like
handfuls of Lego bricks.
okay, so the bin is divided up
Right. The bin is divided up
into these partitions.
into these partitions, and then those partitions get spread out to different workers,
Okay.
different nodes in the cluster.
Cool. And then there's this concept of dependencies, which you also call lineage.
Yeah, lineage is essentially the history of how your data has been transformed.
And that's really important.
It is, because it helps us track how we got from that jumbled mess of Legos to the final structured creation.
Right. And sometimes when you're building with Legos, a piece might fall off or you might accidentally step on it.
Oh, yeah, definitely.
And then you need to go back and figure out how to rebuild that.
And that's where lineage comes in.
Yeah.
It's like having a blueprint that shows you every step
Okay.
so you can recreate any lost or damaged part of your data.
And RDDs have this really interesting property of lazy evaluation.
Yeah, it's a key concept in Spark.
So it's like you're describing what you want to build, but you're not actually doing the building yet.
Right, you're not snapping those bricks together until you absolutely have to.
And this is like,
It's like drawing up a plan for your Lego masterpiece.
yeah.
You sketch out the whole thing first,
Uh-huh.
and then only start actually assembling it when you're ready.
Okay. And that gives Spark some room to do some clever things behind the scenes.
It does. It allows for optimization.
Yeah. So if you give it a bunch of instructions, it can kind of analyze all those and maybe reorder them.
Exactly, be more efficient.
For example, if you have two filters,
Mm-hmm.
Spark might realize it can apply them both at the same time
Oh, okay.
instead of doing them one after the other.
And then when it actually comes time to do the work, that's when it refers back to that lineage.
Exactly. Especially when things go wrong, right? Like if a partition is lost, which is like, one of our little piles of bricks disappears.
It can rebuild that missing partition using the lineage.
Right.
Without having to start from scratch.
So it knows exactly how it got to that point
Precisely.
and can just recreate those steps.
It's incredibly efficient.
Okay, so when would you use these individual loose bricks?
So RDDs shine when you have unstructured or semi-structured data.
Okay.
Things like raw text documents or maybe complex binary files.
Mm-hmm.
Data that doesn't neatly fit into random columns.
Okay.
Or if you need a very high degree of control
Okay.
over your processing logic,
Mm-hmm.
like you have a unique algorithm you need to implement.
So it's like when you have a really unique Lego creation in mind,
You got it.
that doesn't fit any standard kit.
Yeah,
And you need to manipulate every single brick in a very specific way.
exactly. You need that fine-grained control.
But there's got to be some downsides to this, right?
There are always trade-offs.
Yeah.
So when you're dealing with structured data, data that fits nicely into a table with rows and columns.
Like a database table or something.
Exactly.
Okay.
RDDs might not be the most efficient choice.
And also, you mentioned, performance critical tasks.
Yes, because RDDs don't automatically benefit from Spark's advanced optimization engines.
It's like you're building without any instructions or any pre-engineered components.
Yeah.
You have to figure everything out yourself.
And that can be time-consuming and error-prone.
Okay. And you specifically call out that RDDs do not benefit from Spark's Catalyst Optimizer
Yeah.
or the Tungsten engine.
Those are two powerful components.
Can you tell us a little bit about those?
Catalyst is like a super smart planner
Okay.
that figures out the most efficient way to execute your Spark operations.
Uh-huh.
It looks at your code.
Okay.
And comes up with an execution plan
Okay.
that minimizes data shuffling and maximizes parallelism.
So it's doing a lot of the heavy lifting.
It is. It's taking care of the optimization for you.
Okay. And what about Tungsten?
Tungsten focuses on low-level performance.
Okay.
It improves things like memory management
Uh-huh.
and data serialization.
Okay.
It's like fine-tuning the engine of your Spark application.
So you can squeeze out every bit of performance.
Exactly.
Now, your notes also talk about some other things to consider when working with RDDs, like partitioning.
Partitioning is how you divide up your data
Okay.
across the cluster.
And you can do that manually?
Yes, you can manually decide how to group your data
Okay.
using methods like repartition and coalesce.
So it's like taking that big bin of Legos and deciding how you want to divide it up into smaller containers
Exactly.
before you start building.
And you have to be strategic about it.
Uh-huh.
If you don't partition your data well, it can lead to performance bottlenecks.
Okay. And then you mentioned caching, which allows you to store an RDD in memory.
Right. Caching is like keeping your most frequently used Lego bricks within easy reach,
Okay.
so you don't have to go digging through the bin every time you need them.
But with RDDs, you can only cache the whole partition.
That's correct. It's all or nothing.
Okay, so like the whole little container of Legos.
Yeah.
Either it's all in memory or none of it is.
You can't just cache a few bricks from a container.
Okay, and finally, let's talk about schema evolution.
So schema evolution is about handling changes in the structure of your data
Uh-huh.
over time.
Okay.
What happens when you add a new column to your data?
Like you decide you want to add a new feature to your Lego creation?
Exactly.
Okay.
With RDDs, there's no built-in support for this.
So you have to manually update everything.
You have to update your code to handle those changes.
Right.
And that can be quite tedious.
Okay, so that gives us a really good overview of RDDs.
Okay.
Very flexible, lots of control,
Mm-hmm.
but also requires a lot of manual effort.
Yeah, especially when it comes to optimization.
Now let's move on to data frames, which you describe as Lego kits with instructions.
Much more organized.
Yeah, that sounds a lot nicer to work with.
Definitely.
So can you tell us about data frames?
Data frames are essentially tables, distributed tables with named columns.
Okay.
They're built on top of RDDs,
Mm-hmm.
but they add this crucial layer of schema awareness.
Okay, so
They know what the data looks like.
yeah, it understands the structure.
Exactly.
And that makes a huge difference.
So it's like getting a Lego kit where all the pieces are pre-sorted into bags
Right.
and you have a nice instruction manual.
Yeah, and you know exactly what each piece is for and how it fits into the overall structure. And you highlight 3 key features of data frames.
Mhm.
They're schema aware,
Yes.
they benefit from the Catalyst Optimizer,
Right.
and they use the Tungsten execution engine.
Exactly.
So we already talked about Catalyst and Tungsten, but can you tell us a little bit more about how they specifically work with data frames?
Sure. Catalyst is even more powerful when it comes to data frames
Okay.
because it can leverage the schema information
Uh-huh.
to make smarter decisions about how to optimize your queries.
Okay.
For example, if you're filtering a data frame,
Mm-hmm.
Catalyst can use the schema to figure out the most efficient way to apply those filters.
Okay.
Maybe you can push those filters down to the data source.
Mm-hmm.
So you're only reading the relevant data from disk, which
That's-
can save a lot of time.
And Tungsten, you said it uses a binary format.
Yes, Tungsten uses a compact binary format
Right.
to store data in memory,
Uh-huh.
which reduces memory usage
Okay.
and speeds up data access.
So it's like using a more efficient way of snapping those Lego bricks together.
Right, making the whole structure more compact and robust.
And you also mentioned that data frames in Scala and Java are implemented as a data set of row objects.
Yes, that highlights the close relationship between data frames and data sets,
Okay.
which we'll talk about more in a bit.
So it's kind of a special type of data set
It is.
where each row is this generic row object.
Exactly. It's a common foundation
Yeah.
for both data frames and data sets in the JVM ecosystem.
So when are data frames the tool of choice? When would
Wow.
you reach for this Lego kit?
Data frames are great for structured and semi-structured data,
Okay.
where you have a well-defined schema
Uh-huh.
when performance is critical
Okay.
because you can leverage Spark's built-in optimizations
Uh-huh.
and for SQL-like processing.
Oh, okay. So like you want to do selections.
Yeah, filtering, grouping, aggregation,
Yeah.
joins,
Yeah.
all those classic SQL operations.
And they also work well with BI tools.
Yes, many BI tools understand data frames.
Okay, so it's like you have a clear building plan. You want to build your Lego kit quickly
Right.
and efficiently.
We rely on those instructions.
Yeah, and let Spark kind of handle all the details.
Spark takes care of the optimization for you.
Are there any times when data frames might not be the best choice?
There are a few cases where you might consider other options.
Okay.
For example, if you need compile time type safety,
Hmm?
which is the ability to catch errors
Okay.
during compilation,
Uh-huh.
data frames don't provide that.
Okay.
So if you're working in Scala or Java
Mm-hmm.
and you want that extra level of safety,
You might consider data sets instead.
Okay.
Also, if you're dealing with completely unstructured data,
Okay.
the schema might not be very helpful,
Yeah.
and you might be better off with the flexibility of RDDs.
All right, so let's dig into some of these additional considerations for data frames.
Okay.
So we talked about partitioning, but it's a little different with data frames, right?
It can be.
Yeah.
Spark can often figure out the partitioning automatically.
Oh.
If you're reading data from a source like HDFS
Uh-huh.
or cloud storage,
Okay.
Spark can detect how the data is organized
Okay.
and leverage that existing partitioning.
So it's like opening your Lego kit
Yeah.
and finding that all the pieces are already sorted
We
into
don't-
different bins for
You
you.
don't have to do it yourself.
Yeah.
Spark's got you covered.
Awesome. And then caching with data frames is more efficient
It is.
because of this columnar storage.
Yes, columnar storage is a key optimization.
Can you explain that a little bit?
Sure. So instead of storing data row by row,
Columnar storage stores all the values for each column together.
okay.
It's like having a separate container
Yeah.
for each type of Lego brick.
Okay.
All the red bricks together, all
Yeah.
the blue bricks together,
Oh, okay.
so on.
And that makes it faster
It does.
to access values.
Yeah, because you can read just the columns you need
Okay.
without having to scan through the entire row.
And finally, schema evolution with data frames. It's more flexible.
It is.
Yeah.
Data frames can handle schema changes more gracefully.
Okay, so like if you add a new column or change a
Like you-
data type.
Spark can often adapt those changes
Okay.
without breaking your code.
All right, so data frames. Kind of a step up from RDDs
Definitely.
in terms of ease of use and performance.
They're a great all-around choice
Yeah.
for most data processing tasks.
Now let's move on to the final abstraction,
Data sets.
data sets, which
Whoops.
you describe as.
The premium, perfectly fitting Lego kits.
Okay, so this is like the top of the line.
It's
Lego experience.
the best of both worlds.
Yeah.
You get the type safety and expressiveness of RDDs,
Mm-hmm.
combined with the performance of data frames.
Okay.
It's like having a Lego kit where every piece is guaranteed to fit perfectly.
And what are the key features that make data sets so special?
First and foremost, compile time type safety.
So that means you can catch errors early on.
Yes, during compilation, before you even run your Spark application.
So it's like checking your Lego instructions before you start building.
Exactly. Make sure all the
Fantastic.
connections
Well,
make sense.
And that prevents a lot of headaches.
It does,
There.
especially in large and complex projects.
And you also mention typed encoders, which are responsible for serializing and deserializing.
Yes, encoders handle the conversion
Okay.
between your high-level objects
Mm-hmm.
and Spark's internal representation.
Okay. And they're very efficient
They are.
because they're tailored to
Yeah.
the specific data types.
Exactly. They
Mhm.
know exactly how to handle each type of data.
Now, one important thing to note is that data sets are only available in Scala and Java.
Right.
And that's because...
It's because of the requirement for static typing.
Okay.
Data sets need compile time type safety,
Uh-huh.
which is something that Python doesn't provide.
Okay. Python being dynamically typed
Yeah.
doesn't have that same level
Yeah.
of type checking at compile time.
Exactly.
So when would you choose to use these premium, perfectly fitting data sets?
Data sets are ideal when type safety is paramount.
Okay.
When you're working on a complex project
Uh-huh.
with lots of custom data types,
Okay.
and you want to catch errors early.
It's like when you're building a mission-critical Lego structure, where precision and correctness are essential.
You got it.
But if you're doing something simpler, or if performance is your absolute top priority, you might consider sticking with data frames,
That's right.
even in Scala or Java.
Data frames can sometimes be a bit faster
Okay.
because they have less overhead.
And optimizer support for datasets is very similar to data frames. It still benefits from Catalyst,
Yes.
and it uses tungsten encoders.
But the encoders are specialized
Okay.
for the data types in your data set.
So it's like having a Lego expert who not only knows the best building techniques, but also has special tools for each type of brick.
Exactly.
And then those additional considerations. Partitioning and caching are similar to data frames,
Right.
but they preserve the type information.
Yes, because data sets are type safe.
Okay.
The partitioning and caching operations also respect those types.
But schema evolution can be more challenging
It can be.
because of the static typing.
Right. If you change your data types, it can break compatibility with existing code.
Okay.
It's like trying to fit a new type of brick
Yeah.
into an existing Lego structure.
Might not work so well.
It might require some modifications.
Now, we've covered a lot of ground here. We talked about RDDs, data frames,
And data sets.
and this Lego analogy has been incredibly helpful in understanding these concepts. So let's shift gears a little bit and talk about some of these points to ponder that you've outlined in your notes that really help to solidify our understanding.
These are some key takeaways that I want you to think about.
So first up is lazy evaluation. In RDDs,
Right.
how does delaying the execution actually improve performance?
It gives Spark the opportunity to optimize.
Okay.
It can analyze the entire sequence of operations and come up with the most efficient execution plan.
So it's like planning your entire Lego build before you even touch a brick.
Exactly.
Okay.
You figure out the best order of steps, identify any potential shortcuts,
Okay.
and make sure you have all the right pieces.
And then RDD lineage. How does that provide fault tolerance?
Lineage is like a safety net
Yeah.
if something goes wrong.
Uh-huh.
And you lose a partition of data.
Like you lose a section of your Lego model.
The Spark can use the lineage to rebuild that missing partition without having to start the entire job over.
So it's like having a backup copy of your Lego instructions.
Got it.
Oh.
You can always go back and reconstruct any lost parts.
Now, when would you choose to use RDDs over these newer abstractions?
That's a good question.
Yeah.
RDDs are really only necessary
Okay.
in a few specific scenarios.
Okay.
When you need that absolute low-level control, when you're dealing with truly unstructured data,
Okay.
or when you're implementing a highly specialized algorithm.
So it's like when you're building a very unique Lego creation that requires custom techniques.
Yeah.
But for most common data processing tasks, data frames or data sets are going to be a better choice.
They're more efficient
Yeah.
and easier to work with.
And how does the Catalyst optimizer really make data frames so much faster?
Catalyst is like a performance guru.
Okay.
It knows all the tricks
Right.
to make your Spark queries run as fast as possible.
Okay.
You can reorder operations, eliminate unnecessary steps, and choose the most efficient algorithms.
So it's like having a Lego master builder guiding you every step of the way.
Exactly.
And schema inference. How does Spark figure out the structure of your data automatically?
Schema inference is like magic.
Okay.
Spark can look at your data and figure out the schema
Okay.
without you having to tell it explicitly.
So it's like opening a Lego kit and knowing exactly what pieces you have just by looking at them.
Spark can do that with data.
And data frames are represented a little differently across different languages.
Yes, there are some subtle differences
Okay.
in how data frames are implemented in Scala and Java versus Python.
And that's because Python has a different type system.
Exactly.
Okay.
Python is dynamically typed, while Scala and Java are statically typed.
So what are the key differences between data sets and data frames?
Datasets are type safe,
Okay.
while data frames are not.
Okay.
Datasets provide a more functional programming API, while data frames focus on relational operations.
Okay.
Datasets work with your custom objects, while data frames use generic row objects.
And data sets are only available in Scala and Java.
Right.
And why is that?
Because Python lacks static typing,
Okay.
which is essential for datasets.
So when it comes to performance, Are there any trade-offs between data sets and data frames?
Generally, data frames are slightly faster
Okay.
because they have less overhead, but data sets can be more efficient
Okay.
for certain types of operations.
So it really depends on your specific workload.
It does.
And it's always a good idea to benchmark.
Always benchmark.
Okay. So we've really explored these three main abstractions.
RDDs, data frames, and data sets.
In Apache Spark. And hopefully you have a much better understanding of them now.
I hope so.
Yeah.
They're the building blocks of Spark.
Yeah.
And once you understand them, you can build anything.
I love that. And thanks for sharing your Lego analogy. It really helped.
It's a great way to visualize these concepts.
To make it all click. So one final thought for you to ponder.
Okay.
As data continues to evolve and change, how might these Spark abstractions need to adapt as well?
That's a great question.
Yeah.
It's something we all need to think about.
Because the world of data is always changing, so Spark needs to keep up.
It does.
All right. Thanks for joining us for this deep dive.
My pleasure.
And we'll see you next time.
See you next time.